Okay, so headphones out of your ears, stop looking at your phone screens. Today we did the first official lesson. Yesterday was more of a pre-lesson. Today was the first official lesson of Unit 4, which is all about functions. So you learned very generally how to tell if something's a function when you know what the coordinates are or what the graph looks like. Today we're attaching it to real world situations. So understanding independent and dependent variables are part of that. What are independent variables? What else do we call them? Y values. All right. And the way that you can easily remember that, because you do need to tell if something's independent or dependent so that you plot them on the right spots, is that you can make a D with the y-axis, not with the x-axis, right? So our dependent variables are y values, our independent variables are x values. So yeah, something that's usually independent is time, for example. Time is almost always on the x-axis. Whatever goes on the y-axis has to be what depends on the x, okay? And then we also looked at different descriptions and graphs of functions and explain what they tell us about situations. We got through almost the entire note sheets. The part that we didn't get to, I still think is important. And I feel like maybe it'll make more sense when we talk about function notation. So maybe I just have to wait until next week to bring it up again. But we normally say function of x. So when we say blank is a function of blank, we're saying whatever the y variable was is a function of whatever the x variable was. So like when we're talking about our bagels and the best price is a function of however many bagels we buy. All right, so function of x, which we'll talk about more after function notation. I think it'll make a little more sense. But for right now, just be able to describe situations, identify whether or not they are functions. What else? They're independent and dependent variables. Your practice is in Schoology. I didn't take a picture of it, but it matches this title. This is the one that since you're all here, I expect you to get done today. Like there's no reason you spend a whole hour in here and can't submit it at least once. It's definitely no missing from anyone. But 80% or higher. And then you can work on other things after that, like your practice from yesterday. If you didn't have that done when I checked, I did put the key for that practice on my whiteboard back there. So you can, if you weren't finished yesterday, look at it and then we'll see if you're right. Always going to be practicing it right. And that's all for today. So just ensuring we do our practice for the lessons so that we don't have homework. And then I would recommend IXL skills after that. Any questions right now? All right, so then I shouldn't see anyone having free time until this is at 80% higher. And this is a practice from today, number 1. The relationship between the amount of time a car is parked in hours and the cost of parking in dollars can be described with a function. Which elements about the function are true? Select all that apply. So the cost of parking is dependent. Before you say I would like to knowing that what's independent goes on the x and what's dependent goes on the y. The two things that are being compared is the amount of time a car is parked in hours versus the cost of the parking in dollars. So we're comparing hours to costs. What is more independent? What can you never really change? Time. So hours will go on the x, and the cost in dollars will go on the y. And In that case, is the cost of parking the dependent variable? It is, because when I make my little graph, it goes here, and I can make it be with the y-axis, not with the x-axis. So I will select that as one of the answers. The amount of time that the car is parked is the independent variable. Do you guys agree with that? Okay. The parking cost is a function of the amount of time a car is parked. So that's the part we didn't necessarily get to, but I tried to tell you when we were doing our roaming targets. It's always function of x. So when it says function of, that's your variable that goes on your x-axis. So, and then the other one would be y. So y is a function of x. So the cost of parking is a function of the amount of time the car is parked. Do you guys agree with that? Y and then x. Okay. Suppose it costs $3 per hour to park with the maximum cost of $12. This graph represents the function. So we're saying if that's true or not. So if it costs $3 an hour to park, how much does it cost for 1 hour? No, look at the graph, because we're trying to see if this graph is right. So if it costs $3 an hour to park, how much does it cost for 1 hour? $3. So see, if that's true, then at the 1 hour mark, I should have a line touching here. Do I? No. I mean, the 12 for being like the rest of the time, sure. But that doesn't match this graph, so I'm not going to select this option. It says, suppose it costs $3 per hour to park with a maximum cost of $12. So how much does it cost for 1 hour of parking? So I'm not looking at the graph. Okay, $3. How much does it cost for 2 hours? If it costs $3 an hour. Okay. What about 3 hours? All right. So far it's looking good. $4. Okay. 12, and then it says the maximum was 12. So beyond that, it should all be $12. So this one is a graph representing that stipulation. And then it says the 0.39 means that it costs $3 to park for 9 hours. What order are coordinates always in? X and then Y. So is that my X variable, the cost? So don't pick that one. Pick the one that says the 0.39 means it costs $9 to park for 3 hours. Time and then the cost. Put on that one. That was a lot of parts. We make sure the key is right. And that it gives our credits. Okay, and it does. All right, questions on this one? Questions on any others? Or any question? Question 3 on today. Okay, so the distance a person walks d in kilometers is a function of time t in minutes since the walk begins. Select all true statements about the input variable of this function. So again, I think it's helpful labeling the coordinate plane. We are comparing the distance a person walks in kilometers to time. What should go on my x-axis? Time in minutes. Good. Time is almost always on the x. It also did say function of. So what follows that should be whatever the x variable is. And then my y-axis is kilometers. distance the other person wants. All right, so then it said select all true statements about the input variable. Input is your X or Y. Input is your X value or your Y value. Okay, so we're answering questions about the input variable, which is our. All right, so distance is the input, true or false? So don't pick that one. Time of day is the input. I would say no, because it's time in minutes since the walk begins. So it's not the time of day. So don't pick that one. Meant to trick you. C, time since the person starts walking is the input.
Yes, true.
Yes. T represents the input. Like for time, did they say use a certain variable? Okay, T represents the input. D represents the input. Okay. The input is not measured in any particular unit. So that would be like, if we're talking about time, a unit for time would be like seconds, hours, minutes. Does it say that the input's not measured in any particular unit? Do I pick this option or not? Okay, don't pick it because it is measured in a particular unit. It's measured in minutes. So don't pick that one. Let's see. The input is measured in hours. Do you guys agree with that? No, it's measured in minutes. For each input, there are sometimes two outputs. So let's think about that. If the y-axis is the distance a person walks in kilometers, could there ever be like an X with multiple Y's? No, you can only be walking one distance at every minute, I suppose. It's kind of tricky, I don't know. Because in a minute, you could walk like a distance, I don't know, have two different Y's. Let's see what the key says. Nope, it just wants you to pick those. So only pick those two. Because really, yeah, you can only be one distance at a time. I don't know if that's how the graph would look, but like earlier when we were doing the peer deck, some people have their graph looking like this, right? Like that would never happen. Like you only have one distance at a time. Good on that one? All right, any questions on others? Anything for anything else? Awesome. On today's question 2. The prices of different burgers are shown on the sign. And based on the information, is the price of a burger a function of the number of patties? So they're saying, is the number of patties X and the price Y? Remember, it goes function of X. So would you guys agree with that? Is the number of patties more independent than the price? Okay. Lots of people shaking their head no. Let's see what this says. So probably yes or no. There are blank possible prices for 2 patties. There are 1 or 2 prices for 2 patties. There are 2 different prices. Which means blank outputs for the same inputs. 2 outputs for the same inputs. So would that make it a function, yes or no? We have 2 Y's for the same X, I would make it not a function. All right, so even though, like, when I was first going to label this, it would have been number of patties compared to price. what it was really asking was like, would there ever be an instance where one X has multiple Ys? And it would, it's two patties, has two different prices. Questions on that one? All right, questions on any others? All right, so then if you think of any others, let me know.